Let's discuss questions related to skew lines. So the question number 1 is, prove that the locus of line which meets the line this and the circle is this. So we are supposed to prove that locus of a line which meets two given lines and a circle is this given relation. So the first line is, my L1 is y equals to mx, z equals to c, and my line L2 is y equals to minus mx, z equals to minus c. So equation of line passing via L1 and L2, basically equation of line meeting L1 and L2 will be intersection of planes y minus mx plus lambda z minus c equals to 0 and y plus mx plus, let's say, mu z plus c equals to 0. So the intersecting lines of these two planes will be the equation of line which will be meeting this given line. So let me name it as 1. So it is also given in question that this line also intersects the circle which is x square plus y square equals to a square and z equals to 0. So if the variable line meets this line and the circle, then we can substitute z equals to 0 in this variable line to see if we could find any relation. So putting z equals to 0 in 1, we'll get y minus mx plus lambda minus c equals to 0 and y plus mx plus mu into c equals to 0. Further, it says that x square plus y square equals to a square is the relation. So from here what we can do is we can just find out the values of x and y, because we have two equations in x and y. So we can solve it using cross multiplication. So we'll get minus m mu c plus m lambda c equals to minus y equals to x upon mu c plus lambda c equals to 1 upon m plus m. So we got our x as c mu plus lambda upon 2m and our y as mc lambda minus mu upon 2m. This m balances out this one. So I got my y as c by 2 lambda minus mu. So also in the question it is given that x square plus y square equals to a square. So substituting value of x and y in that relation, I'll get x square plus y square equals to a square. So from here I'll get c square by 4m square mu plus lambda square plus c square by 4 lambda minus mu square equals to a square. So if I further simplify it, I'll get c square mu plus lambda square plus c square m square lambda minus mu square equals to 4a square m square. Now I got a relation in between mu and lambda. So if somehow I could eliminate this mu and lambda, then I'll get the locus of required equation of line. So using 1, I can easily eliminate mu and lambda. So using 1, my lambda is minus of y minus mx upon z minus c. So using that, my lambda is minus of y minus mx upon z minus c, and my mu is minus of y plus mx upon z plus c, minus of y plus mx upon z plus c square plus c square m square minus y minus mx upon z minus c plus y plus mx upon z plus c square equals to 4a square m square. So if I simplify it further, I'll get c square y minus mx z plus c plus y plus mx z minus c square plus c square m square y plus mx z minus c minus y minus mx z plus c whole square equals to 4a square m square z square minus c square whole square. So if I simplify it further, I'll get c square yz minus zmx plus yc minus mcx plus yz plus mxz minus yc minus mcx square plus c square m square yz plus mxz minus yc minus mxc minus yz plus mxz minus yc plus mxc square is equals to 4a square m square z square minus c square whole square. So let's see if we can balance out some terms. Minus z mx, this one balances out this one, yc balances out this one. So we are left with, it is c square into 4 yz minus mcx square plus in second term mcx, this one balances out this one and yz balances out this yz. So we are left with 4c square m square mxz minus yc whole square equals to 4a square m square z square minus c square whole square. Is this what we are supposed to prove? 4 also balances out, c square yz minus mcx whole square plus c square m square mxz minus yc whole square equals to a square m square z square minus c square whole square. So we are supposed to prove c square m square cy minus mzx, cy minus mzx plus c square yz minus cmx equals to, yeah, this is what we are supposed to prove. There is just difference of negative sign in whole square and we can just get rid of that because it is also equivalent to mcx minus yz whole square plus c square m square yc minus mxz whole square equals to a square m square z square minus c square whole square. So there is a lot of calculation involved in this one. So what you can do is at this step, to avoid this much of calculation, what you can do is you can just assume as x equals to a cos theta and y equals to a sin theta. So there won't be this much calculation then. That will just simplify your process and maybe save some time in examination. So let us move on to next question. So the next question says that find the surface generated by a line which intersect the lines this and parallel to the plane. So equation of line, so my line L1 is y equals to a equals to z. I can also write it as y minus a equals to 0 and z minus a equals to 0. And my equation of line L2 is x plus 3z equals to a equals to y plus z. like we did in for equation number 1, we can also write it as x plus 3z minus a equals to 0 and y plus z minus a equals to 0. Let us name it as 1 and this one is 2. So we are supposed to find a surface which is generated by line L1 and line N2, and that surface is also parallel to the given plane. So equation of plane via line L1 will be something like this: y minus a plus lambda into z minus a equals to 0. So if we just simplify it, we'll get y plus lambda z minus a minus lambda a equals to 0. And equation of plane via line L2 will be x plus 3z minus a plus mu into y plus z minus a equals to 0. And if I just simplify this one also, I'll get x plus mu y plus 3 plus mu z minus a minus mu a equals to 0. So we are in question, they have asked, so these are this, let me name it as 3 and this one as 4. So we are supposed to find surface which intersect both line L1 and L2. So equation of line which is intersecting both line L1 and L2 will be same as equation of line of intersection of plane 3 and plane 4. So let's say this is my plane 3 and this is my plane 4. So this is the line of intersection of line L1 and L2. Further, it says that this line of intersection is parallel to plane x plus y. So we can say that we can find out direction cosines of this line of intersection, and then this direction cosines of this line of intersection will be perpendicular to the normal of the plane x plus y equals to 0. So let L, M and N be direction cosines of line of intersection of plane 3 and 4. So it will be, so we'll get, using perpendicularity result, we'll get L into 0 plus 1 into M plus lambda into Z equals to 0 and 1 into L plus mu into M plus 3 plus mu into Z equals to N. Sorry, it's N not Z. So using cross multiplication we can solve it for L, M and N. So it will be 3 plus mu minus lambda mu equals to minus M upon minus lambda equals to N upon 0 minus 1. So my direction cosines are L upon, so direction cosines of line of intersection are 3 plus mu minus lambda mu comma lambda comma minus 1. So any line proportional to any line with direction cosine these is perpendicular to normal of plane x plus y. So you again using perpendicularity result, we'll get 1 into 3 plus mu minus lambda mu plus 1 into lambda minus 1 into 0 equals to 0, because direction cosines of normal to x plus y equals to 0 plane are 1 comma 1 comma 0. So if I just simplify it, I'll get 3 plus mu minus lambda mu plus lambda equals to 0. Now I got a relation in mu and lambda. So if somehow I could just eliminate these mu and lambda from here, so I will get locus of the required line, basically the surface which is generated by intersection of this line and parallel to the given plane. So using equation number 3, using this equation, I can find lambda. So my lambda is minus y minus a upon z minus a. So it is 3 plus minus y minus a upon z minus a minus y minus a minus of minus y upon z minus a, and my mu will be, from here I'll get my mu as minus of x plus 3z minus a. It is minus minus plus minus of x plus 3z minus a upon y plus z minus a, y plus z minus a, which is x plus 3z minus a upon y plus z minus a equals to 0. So if I simplify it, I'll get 3z minus a y plus z minus a minus y minus a into y plus z minus a minus of y minus a into x plus 3z minus a minus of z minus a into x plus 3z minus a equals to 0. So if I simplify it further, I'll get z minus a 3y plus 3z minus 3a minus x minus 3z plus a, and minus of y minus a, y plus z minus a plus x plus 3z minus a equals to 0. I just took z minus a common from first and the last term, and minus of y minus a common from the middle terms. So if I simplify it, this 3z balances out this one. So we are left with z minus a 3y minus x minus 2a, 3y minus x minus 2a minus y minus a x plus y plus 4z minus 2a equals to 0. Now let's just open it up to see what we get. So it is 3yz minus 3ay minus zx plus ay minus 2az plus 2a square minus of yx minus ax plus y square minus ay plus 4yz minus 4az minus 2ay plus 2a square. If I take this minus side inside, I'll get here positive, negative, positive, negative, positive, positive, and negative. So let's see if something cancels out. 3 of yz minus 4 of yz, so it is minus yz minus 3ay plus ay minus 2ay minus ay plus 2ay. So we are left with plus ay and zx. This minus 2a square balances out this one, and zx, I think this is the only term, zx. Yeah, minus zx minus 2az plus 4az, which is plus 2az, and minus yx plus ax minus y square equals to 0. So what we're supposed to prove is, okay, we are just supposed to find the surface. We are not supposed to prove anything. So I guess this is the required surface. Let's see if we could simplify it further. We can take y common from these terms. So if I take y common, minus y, z minus a plus x minus y, and then from here I can take z common, maybe, plus z into 2a minus x plus ax equals to 0. We're not getting anywhere. I think we can left it here, or maybe we have done some calculation mistake. You can check it afterwards. Till here it is correct. Maybe we have done some calculation mistake. Y plus z, 3 into z minus a, y plus z minus a, minus y minus a, and then minus y minus a, y 3 plus z minus a, minus, is it 3 plus z minus a, x plus 3z minus a, yeah, and then here's again z minus a, yeah, till here we are right. Then where did we get wrong? Maybe there's some calculation mistake here, or we are just correct, so we can see it later. So let's move on to next question. So next question says that find the locus of variable straight line that always intersects line 1, line 2 and line 3. So my line L1 is x minus 1 equals to 0 and y equals to 0. Line L2 is y minus 1 equals to 0 and z equals to 0. And my line L3 is z minus 1 equals to 0 and x equals to 0. So I can find plane which passes via line L1. So equation of plane which contains L1, so it will be somewhat like x minus 1 plus, let's say, lambda 1 y equals to 0. Likewise, equation of plane which contains L2 will be y minus 1 lambda 2 into z equals to 0. Similarly, equation of plane which contains L3 will be z minus 1 plus lambda 3 into x equals to 0. So we are supposed to find the variable straight line that intersects the given line. So it is basically asking us to find the line of intersection of these three planes, and we have a formula. Like when we study skew lines, we have a formula to check like whether the three equation of planes intersect at a point or at a line, or they form a prism sort of thing. So from that we got that if we take determinant of coefficients of x, y, and z equals to 0, then we can say that the three planes intersect at a line. So using that formula, we'll see what is coefficient of x in plane 1, it's 1, and y, for y it's lambda 1, and z it's 0. Likewise for line L2 it's 0, 1, lambda 2, and for L3 it's lambda 3, 0, 1. It must be equals to 0. So if we simplify this, we'll get 1 into 1 minus 0 minus lambda 1 into minus lambda 2 lambda 3 equals to 0. So we got a relation 1 plus lambda 1 lambda 2 lambda 3 equals to 0. So if this relation satisfies, then our three equation of planes intersect at a line. So if we could just eliminate lambda 1, lambda 2, lambda 3 from this relation, we'll get the locus of straight line, which is basically the intersection line of these three planes. So using these equation of planes, we'll eliminate lambda 1, lambda 2, lambda 3. So my lambda 1 is minus of x minus 1 upon y. My lambda 2 is 1 minus y upon z, and my lambda 3 is 1 minus z upon x equals to 0. So if I simplify it, I'll get x, y, z plus 1 minus x, 1 minus y, 1 minus z equals to 0. So this is my locus of the line, which is basically intersection of these three lines. So let's discuss next question. So next question says that prove that the locus of variable line which intersects these three lines is this given surface. So my line L1 is y equals to mx, comma z equals to c. My line L2 is y equals to minus mx and z2 equals and z equals to minus c. And my line L3 is y equals to z and mx equals to minus c. So equation of plane passing via line L1 will be y minus mx plus lambda 1 into z minus c equals to 0, and equation of plane passing via line L2 will be y plus mx plus lambda 2 into z plus c equals to 0. So if my variable line will basically be the intersection of these three lines. So it will be basically intersection of these two lines, and this third line must also satisfy that intersection. So this line y equals to z and mx equals to minus c must also satisfy the equation of line of intersection that I'll get using these two planes. Let's name these two planes as star. So y equals to z comma mx equals to minus c must satisfy star, because this is also intersecting the variable line. So if I substitute y equals to z and mx equals to minus c in the above equation of planes, I'll get y equals to z, so it is z minus at place of mx I'm supposed to substitute minus c, so it will be z plus c plus lambda 1 into z minus c equals to 0, and from second plane I'll get z minus c plus lambda 2 into z plus c equals to 0. So using these two, I can easily find out a relation in between lambda 2. So if I calculate lambda 1 as, my lambda 1 will be minus of z plus c upon z minus c, and my lambda 2 is minus of z minus c upon z plus c. So clearly lambda 1 into lambda 2 is equals to 1. Yeah. So I can, from equation of plane, I can substitute value of lambda 1 and lambda 2 to get the locus of surface which is intersecting the three lines. So my lambda 1 is minus of y minus mx upon z minus c, and my lambda 2 is minus of y plus mx upon z plus c equals to 1. So if I simplify it, I'll get y minus mx into y plus mx equals to z minus c into z plus c. If I further simplify it, I'll get y square minus m square x square equals to z square minus v square, and this is the exact surface which we are supposed to prove. Yeah, we can also do it by assuming third plane as well, and we can use the condition wherein three planes intersect at a line, but I think that will just complicate the calculation. So this one is fine for example, but you can try that at home. So my next question is, and I guess this is the last question on this topic of skew lines. So this question says that a line is drawn through variable point on the ellipse this to meet the two fixed lines this, and we're supposed to find the locus of the line. So we are given equation of ellipse. So my equation of ellipse is x square by a square plus y square by b square equals to 1 comma z equals to 0, and my equation of two lines are L1, which is y equals to mx comma z equals to c, and my line L2 is y equals to minus mx comma z equals to minus c. So I can find equation of plane which is passing via L1. So it will be y minus mx plus lambda 1 into z minus c equals to 0. Likewise, equation of plane passing via L2 will be y plus mx plus lambda 2 into z plus c equals to 0. Further, it is given that a line is drawn through a variable point on ellipse, and that line is meeting the intersection of these two planes, basically line of intersection. So if a variable point lies on this ellipse, then z coordinate of that variable point must be 0, and that must satisfy this equation of planes as well. So using that logic, putting z equals to 0, we'll get y minus mx plus lambda 1 into minus c equals to 0, and y plus mx plus lambda 2 into c equals to 0. Now I can easily solve it for x and y. So if I solve it for x and y, I can just add these two equations. On adding these two equations, I'll get 2y plus c into lambda 2 minus lambda 1 equals to 0. So from here I got my y as minus of c by 2 lambda 2 minus lambda 1, which is basically my y is c by 2 lambda 1 minus lambda 2, and if I calculate my x, it will be mx equals to y minus lambda 1 c. So it is equals to c by 2 lambda 1 minus c by 2 lambda 2 minus lambda 1 c, which is minus c by 2 lambda 2 minus c by 2 c by lambda 1, which is minus c by 2 lambda 1 plus lambda 2. So from here I got my x as minus c by 2 m lambda 1 plus lambda 2. Also, since the variable point lies on the ellipse, so my x and y must satisfy equation of ellipse, which is x square by a square plus y square by b square equals to 1. So substituting my values of x and y in this equation, I'll get c square by 4m square a square lambda 1 plus lambda 2 square plus y square c square by 4b square lambda 1 minus lambda 2 square lambda 1 c square by 4 and b square equals to 1. If I further simplify it, I'll get c square b square lambda 1 plus lambda 2 square plus c square m square a square lambda 1 minus lambda 2 square equals to 4a square m square b square. Now I can just substitute values of lambda 1 and lambda 2 to get the required locus. So my lambda 1 is minus of y minus mx upon z minus c. So if I substitute here, I'll get c square b square minus of y minus mx upon z minus c, and my lambda 2 is minus of y plus mx upon z plus c whole square plus c square m square a square. My lambda 1 is minus of lambda 1 minus lambda 2 will be y plus mx upon z plus c minus y minus mx upon z minus c whole square equals to 4a square m square b square. Now if I just simplify it further, I'll get c square b square y minus mx z plus c minus y plus mx z minus c whole square plus c square m square a square y plus mx z minus c minus y minus mx z plus c whole square equals to 4a square b square m square, and that denominator z square minus c square whole square. I can simplify it further by opening these brackets. I'll get yz minus mxz plus yc minus mxc minus yz minus mxz plus yc plus mxc whole square plus c square m square a square yz plus mxz minus yc minus mxc minus yz plus mxz minus yc plus mxc whole square is equals to 4a square b square m square into z square minus c square whole square. Now let's see if some term balances out. This 4xc balances this one. Likewise zx balance yz balances this yz. Yeah, that's it. And in second bracket, yz again balances out yz and mxc balances out mxc. So if I simplify it, I'll get c square b square yc 4 minus mxz. Here it will be 2 yc and 2 of mxz. So I took 2 square outside whole square. Likewise here 4c square m square a square mxz minus yc whole square equals to 4a square b square m square z square minus c square whole square. We can balance out 4 from both sides. So our locus is c square b square yc minus mxz whole square plus c square m square a square mxz minus yc square equals to a square b square m square z square minus c square whole square. These two brackets are also same, mxz minus, yeah, so we can take that out common. So yc minus mxz whole square c square, we can take c square as well. So it is b square plus m square a square equals to a square b square m square z square minus c square whole square. So this is the required locus of the surface which passes through a ellipse and meets two fixed line. So that's all for today. Thank you for watching.